Hello guys and welcome back to a new physics session. Today we are going to start a new part of physics called modern physics. Scan the QR code, which is a video, and turn back to me. Today you are going to explain and understand the particle model of waves. First question we have to answer: does a light wave consist of particles? And what is the difference between different model of spectrum emission series? Let's first know what is the difference between different series. The old theory explains the change in the spectrum as a continuous line. What is the spectrum? A spectrum are the light which is produced by the atom when you heat it up, and it's going to emit radiation as the electron going to move back from the excited state to the ground state. So scientists were describing the emission as a continuous line, which is mean all atoms are able to produce all different spectrum when they are heated. When they are heated between different temperature, only the color produced from this element will be the same. But they found that each element has its own spectrum emitted by this element at a certain temperature, as the frequency change according to the temperature. If you are going to know what happens during the emission of light of a spectrum, the only way to think was that here is the ground state, which is the energy level an electron exists in, and here is the excited state. By absorbing energy, the electron going to transfer from the ground state to the excited state. After that, the electron or this electron going to lose energy and turns back again. While losing energy, a certain amount of energy equal to the difference between the two energy levels will be produced, and this energy is equal to the energy or parallel to the frequency of the light produced, and we call it spectrum. So each element has its own amount of energy produced according to the number of electrons and the difference between energy levels the electron going to move through, which is mean, as described by the old theory, there is no way for each element to produce all spectrum color, as the electron unable to move by different gaps between the two energy level. It has to lose an amount of energy equal to the difference between these energy levels. So the old theory unable to explain the spectrum. Each element has its own spectrum, has its own light when this element is heated up, so it's going to produce a certain color. And the old theory mentions that different elements will produce different spectrum colors. And also, the old theory unable to explain what is the photoelectric effect. Photoelectric effect is the phenomenon when a light falls on a metal, electrons will be produced from the metal to form something called electric current. And this phenomenon, we called it photoelectric effect. The old theory unable to explain this phenomena. So scientists start to search about a new theory that can describe this phenomenon, as the light is wave and the electrons are particles. So what is the relation between a wave and particle? They are unable to interact with each other. There is no way to make collisions. From this point, scientists start to think about that. The light maybe can act like a particle. By this way, if it has some properties of particles, it will be able to make a collision with electron, so it's going to transfer its energy to the electron. Hence, the electron will gain energy to move from one energy level to another energy level, or even to move out of the atom to produce an electric current. So, if we approved that there is one of the properties of matter, of particles, to the light, we will be able to say that the light has some properties of particles and can act like a particle. So guys, as we said, we have two theories that explain the spectrum emission. Electromagnetic wave theory as the one which describes the light as only electromagnetic wave. Electromagnetic wave theory would allow atoms to continuously radiate energy, which is light, with different frequencies. So it's going to emit radiation all of the time. While modern theory, the quantum theory, the new one, atoms emit radiation only at a particular moment when their vibrational energy changes as the electron is going to move from excited state to ground state. As we can see, here is the continuous emission of electrons described by electromagnetic wave theory, and here is the slope which is described by the modern one, the observed spectrum. At a certain temperature, the top of the peak describes the amount of, or the frequency of a certain spectrum produced from the atom. Here is the graph. We can use it to describe the modern theory. By increasing the temperature, we can see that different spectrum are produced. Each one has a certain color. As you can see, guys, the color is changing here. So, by changing the temperature, the amount of energy produced is related to the temperature the atom reached. And as the frequency is related to the amount of temperature, also the wavelength is related to the frequency. So, as you can see, guys, changes the temperature, it changes the wavelength, and also changes the spectral power density, which depends on the frequency of the emitted light. So the scientists found that the temperature is related to the spectrum color produced, as the temperature change the movement of the electron, makes the electron excited from one energy level to another energy level, so it's able to return back from the excited to ground level, emitting the same amount of energy absorbed, which should produce a certain frequency and certain color. In 1900, a physicist, Max Planck, found that he could calculate the correct spectrum if an atom could only emit or absorb particular amount of energy. We are going to call it later a quantum or quanta. This particular amount of energy which the atom going to absorb or release, as we said before, is the difference between the ground and excited energy level. An atom's energy change in a solid where proportional to the frequency of vibration times an integer, which is mean the energy is depending on the Max Planck constant multiplied by frequency. And if we are calculating for different energy levels, so we are going to use n according to the energy level. As we said, n is an integer such as 0, 1, 2, 3, which is the amount of energy levels which is the electron transferred from ground to excited one. So we can say that the energy is quantized. There is a physical term called threshold frequency. Threshold frequency is the minimum wave frequency required to remove an electron from outer energy level. Studying the photoelectric effect, we found that the light is able to remove an electron from the outermost energy level. Here is the electron. So, when the light falls on the electron going to leave the outermost energy level and be free to move and produce electric current. But the removing of electron from the outermost energy level doesn't depend on the amount or the intensity of light falling on the electron, but it only depends on the frequency or energy of the falling light. As this electron required a minimum amount of energy to remove it. By another way or another meaning, if we have a light with energy and frequency, as you know guys, E, energy, is related to the frequency. E is equal to HF. So energy and frequency are directly proportional to each other. If there are light which is falling on the electron at outermost energy level, and this light has frequency or energy less than the required one to remove the electron from the outermost energy level, even by increasing the intensity of the light to reach the maximum value, this light will be unable to remove the electron because there is a certain amount of energy or frequency required to move this electron without giving it any energy to move, any kinetic energy. So the electron just be removed from the outermost energy level without gaining any extra energy. This amount of frequency of energy has a certain definition and scientific term. If we are talking about the frequency, so we are going to call it a threshold frequency. If we are talking about the energy, we are going to call it a work function. So let's first define the frequency. The threshold frequency is the minimum wave frequency required to remove an electron from the outermost energy level. Let's study the three graphs. Here we have a current or have a light which has a constant intensity. So this light has a frequency greater than the threshold frequency. Here is the value of the threshold frequency. And the light has a frequency greater than the threshold frequency. So this light is able to produce an electric current with constant and steady intensity. Doesn't change. The current value doesn't change. But if the light has a constant frequency and this constant frequency is less than the threshold frequency, there is no current will be produced. as there is no enough energy to remove the electron from the outermost energy level, even by increasing the intensity of this light. But here, the light has a constant frequency, and this constant frequency is greater than the threshold frequency. By increasing the intensity, the electric current will increases as the first condition is provided. What is the first condition and the basic condition? That the frequency of the falling light is greater than the threshold frequency. So as we said, the energy of the photon required to remove an electron is described by E equal HF. By another way, we can say that F is the frequency. Frequency is equal to the velocity. As we studied before, velocity is equal to wavelength multiplied by frequency. So the frequency is equal to V over wavelength. F equal frequency equal velocity over wavelength. By changing the term of velocity to c, as we are talking about electromagnetic wave and light, so it has a certain value of the speed, which is equal to 3 times 10 of power 8 meters per second. So the rule can be converted from being hf to hc over lambda, which has a certain value. H is constant, c is constant, so we can say that E is equal to 1240 electron volt multiplied by nanometer divided by the wavelength of the falling light. So the energy depends on the frequency and also depends on the wavelength. The relation between energy and frequency is a direct relation, but the relation between the energy and wavelength is inverse relation. According to Einstein, visible light and other forms of electromagnetic radiation consists of discrete quantized bundles of energy, each of which was later called photons. They called this amount of energy photon, and the energy of the photon differ according to the frequency of the light, emitted light, or the wavelength of the emitted light. As we said before, there are two terms which describes the energy which is able to remove the electron from the outermost energy level. The first one was threshold frequency, and the second one was the work function. The work function is defined exactly like the threshold frequency, but only removing frequency by energy. Is a minimum energy required to remove an electron from its energy level without giving it any kinetic energy. So this one is called work function, which is equal to Planck constant multiplied by the threshold frequency. As we said before from Einstein equation, E is equal to H multiplied by F. So if I'm talking about work function, the frequency itself will be changed into threshold frequency. Okay, let's say that here is the electron, exists in the outermost energy level, and the falling light has an energy which is greater than the work function, which means the electron going to gain amount of energy greater than the amount which is required to remove it from the outermost energy level. Let's say that by another way to make it simply explained. The energy required, which is the work function required to remove the electron from the outermost energy level, is 10 joules. For an example, and the falling light with an energy of 20 joule. So this electron going to be removed from the outermost energy level, taking only 10 joules from the falling light energy, and 10 joules are remained. These 10 joules are responsible for making the electron move with kinetic energy of 10 joules. If the light which is falling to remove the electron has an energy of 10 joules and the electron require only 10 joules, that means the electron will be removed from the outermost energy level without gaining any kinetic energy. So it's going to be just removed and remain constant outside the atom. Any amount of energy added to the work function will be the kinetic energy, which is the electron going to use it to move away from the atom. So we can say that the kinetic energy of an electron ejected due to the photoelectric effect is equal to HF, which is the energy of falling light, minus HF naught, which is the work function. We approved that the photon has energy and has something like a kinetic energy, as it can move with a certain energy. If we are able now to prove that this photon has a momentum, so it has one of the particle properties, with considering that the photon is a quantum of energy and has a momentum without having a mass. We can say that a photon is a particle, guys. Photon is a quantized energy, a certain amount of energy. So it's not a particle by the way to have a mass. It's only a quantized of energy. But it can act like a particle and do some of the properties of particle, like having kinetic energy and doing momentum. So, in addition to having kinetic energy, a photon has a momentum, even though it has no mass. The photon has no mass, guys. Photon momentum P is equal to HF over C. So, H over lambda. This rule is described by or found by comparing the main rule of momentum P equal m times V with the energy and transferring the momentum, conservation of energy, conservation of momentum, with the rule of Einstein, and by the end, the proof you are not required to know or even to memorize, but by the end you have to know that the momentum of the photon is equal to Planck's constant divided by the wavelength. Compton thought that photon-electron collision were similar to the elastic collision, so there is conservation of momentum. By measuring the energy of the electron ejected from a graphite block, Compton found that the energy and momentum gained by the ejected electrons equal to the energy and momentum lost by the photon. So there is a collision happen between electron and photon, and by this way the photoelectric effect is explained, and by this way and this method the light can act like a particle, and it has one of the properties of the particle, which is momentum. So we can say that the dual nature of light is wave, but has some properties of particles. Photons obey the law of conservation of energy and momentum when they collide with other particles. Here is the photon. We are unable to draw the photon as a particle as we do with electron. we only draw the photon as a zigzag line which represents a wave, because we said that the photon is a wave, quantized energy, but it has some properties of particles. The momentum of the photon is calculated by Planck's constant divided by the wavelength, and the energy Planck constant multiplied by frequency. After collision, the energy of the electron is mv, the energy of the photon is hf, the momentum of the photon is h over lambda dash, the total momentum before and after is the same as the collision between photon and electron is an elastic collision. So here we proved that the photon can act like a particle by having momentum. It's the most important point. As Compton was able to find the double nature of photon, there was another scientist called de Broglie. De Broglie was able to describe the particle with something related to the wave nature. As we found a double nature for the wave, he said that we can find the wavelength of the moving particle. He used the Compton equation, B equal h over wavelength. So he modified it to be wavelength is equal to h over momentum B. And we know that the momentum is equal to m times v. So we can calculate the wave joining a moving particle by finding its mass and velocity. As the wavelength of a moving particle is equal to Planck constant divided by m multiplied by v. So not only the light as a wave has a double nature and can act like a particle, also the particle, the moving particle, has a wave property and can act like a wave or have some of the properties of wave. Louis de Broglie proposed that the material particles have wave properties, so it has a double nature, and behaviors such as diffraction and interference. Diffraction and interference are properties of wave. If particles are able to diffract and interfere, so it has some properties of wave. As we said, if light is able to make collision and has a momentum, it has some properties of particles. So de Broglie wavelength is the wavelength associated with a moving particle. It can be found by solving the momentum expression for the wavelength, which is produced by Compton. By the end, if you would like to find the speed of electrons, so the speed of electron is equal to the square root of negative 2q delta V over m. V is the speed of the electron. Q is the charge of electron, which is constant negative 1.602 times 10 to the power negative 19 column. And delta V is the potential difference, and m is the mass of the electrons. So we are able now to find the velocity of the electron. Heisenberg uncertainty principle. Heisenberg said that it's impossible to calculate the position and the speed of an electron accurately at a certain time. It's impossible precisely measure both the position and momentum of a particle at the same time. Here he is talking about the electron. So there is no way to find the position and the speed of electron. even to find its speed accurately and guess its position, or to find its position with guessing its speed, or put it randomly. Which of the following equation represents the energy of photon, E equal hf? Which phenomenon demonstrates the particle nature of light? Photoelectric effect. The Brownian wavelength of an electron with momentum of 3 times 10 to the power negative 24. Simply you are going to use this rule, guys. You would like to find the wavelength. So the wavelength of a particle is equal to h over p, which is the momentum. By dividing h over v, so we'll be able to find the wavelength, which is equal to 2.2. In Compton scattering, which parameter changes after scattering? Energy of the photon will change. Mass of the photon will remain constant. There is no mass of a photon. There is no mass of photon. The speed of the photon is the speed of light, doesn't change. Direction of the photon, yes, the direction of the photon will change. So, energy and direction of the photon. From orbits to an electron cloud. As we know, guys, scientists described firstly the energy levels surrounding the atom is a distinct path of an electron, which is the electron cannot move from one energy level to another one. By this way, each electron has its own energy, and this electron are unable to gain or lose any amount of energy. After that, there was a scientist called Bohr, and Bohr proved the idea of energy level. As the electron moves from one energy level to another energy level by gaining and losing amounts of energy. And this amount of energy is quantized between different energy levels. The electron is unable to gain amount of energy which is not equal to the difference between two energy levels. The energy level which is the electron exists on is called the ground state. If the electron is going to jump from energy level number 1 to energy level number 3, it must gain amount of energy is equal to the difference between the two energy levels. After that, this electron going to lose the energy absorbed in the form of a spectrum, form of light, and returns back to the ground state. From here, the scientists noticed something called absorption spectrum and emission spectrum. Anyhow, guys, the word of spectrum describes the light absorbed or released, whatever. But spectrum is like the fingerprint for elements. Each element has its own spectrum, even to be absorption spectrum or emission spectrum. So, the electron itself, not a wave. The wave describes a probability of finding an electron in particular location or having particular moment or energy. The quantum model of the atom predicts only the probability that an electron is in a specific region, electron cloud, the region in which there is a high probability of finding the electron around the nucleus, because the electron is moving from one energy level to another energy level. So I'm sure that I'm going to find this electron at the electron cloud. Quantum mechanics is the study of the properties of matter using the wave properties. So I'm going to study the properties of the particles, of the matter, but with studying its wave properties. As we said, we have two types of emission. One of them is called spontaneous emission, and the other one is called simulated emission. What is the difference between them? Here is an energy level, ground state of energy level, and here is the excited state. So the electron going to jump, gain an amount of electron to jump between the ground and excited level. After a while, the electron by itself going to lose this amount of energy and returns back to the ground state with releasing a quantized amount of energy called photon, appears in the shape of light or spectrum. This one is called spontaneous. It's done by the electron itself without interference from the human being or another external factor. But here, a ground state for another atom. And here is the excited state. The electron will gain amount of energy to jump from the ground state to the excited state before returning back by itself. I'm going to produce a photon or amount of energy which stimulate the electron to lose its energy and returns back to the ground state under this stimulation. And instead of having one photon, we will have two photons. The one which I produced to make the stimulation process, and the one which is produced by the electron from moving from the excited state to the ground state. The photon of stimulation must have the exactly difference between the two energy levels. As when this electron loses the amount of energy and produce photons, both of them, the two photons, will have the same energy, and by the way will be coherent. They have the same wavelengths, energy, direction, everything similar to each other. This one is called stimulated emission. So the spontaneous emission is the energy released photon when an electron moves back from an excited level to ground level without an interference. While the stimulated emission is the process that occurs when an excited atom is struck by a photon having energy equal to the energy difference between the excited state and the ground state. The atom drops to the ground state. It emits a photon with energy equal to the energy difference between the two states and coherent with the photon, which causes the stimulation process. This is the stimulation process which we described. The stimulation emission, guys, is the main idea of making the laser. Let's describe the laser set and know how does it work. Simply, the laser set depends on the stimulated emission. As the laser set consists of active material. This active material exists between two mirrors. One of them is fully reflective, and the other one is semi-reflective with percentage about 95%. Make the electrons of the active material be excited by producing energy using outer source of energy like electric current, and making all of the energy in the excited state. So electrons are in the excited state now. By producing one photon from one electron, return it back to the ground state, this photon will reflect between the two reflecting surface or between two mirrors. Moving between the two mirrors will make the photon pass through the active material. Photon of the same energy difference between the ground state and excited state, passing by electrons which already excited and exist on the excited state. So something called stimulated emission will occur. So the number of photons the number of photons which are produced will increase. Here a photon returning back, passing by the material. When it gets out of the material, it will not be one photon, it will be two photons, and one of them is stimulated. Reflect back on the mirror, returning back the two photons will be 4 photons, and so on to reach amount of photons unable to be held by the semi-reflective mirror, and can penetrate the mirror to produce a beam of light of coherent photons that are all the photons produced have the same wavelength, have the same energy, have the same frequency. We can call it a coherent source of light. For that, the laser beam is focused on one direction and has a certain energy which cannot be decreased by distance, as the source or the photons are coherent with each other and have the same energy. Laser is a device that produces power for coherent directional monochromatic light. Monochromatic light because it has only one wavelength that can be used to excite other atoms. And laser stands for light amplification by stimulated emission of radiation. Rutherford experiment, guys. Rutherford experiment is the experiment which describes or the scientists used to discover the nucleus. Before Rutherford, there was a scientist called Thomson. Thomson described the atom as a whole sphere, which is positive, and there is distributed charge, negative charge, not electric charge, which is equal in value to the positive charge of the whole sphere. So by the end, the atom as a whole is neutral. So Rutherford tried to think about it. the mass of electron, one electron mass, is equal to 1/1870 of the mass of proton or neutron, which is mean the mass of proton or neutron is equal to 1874 or 70 the mass of electron. So one proton, if one electron stands in front of one proton, this proton with its speed can collide with the electron and move it away, push it away, and continue in the straight line. Rutherford, think about, instead of using proton or neutron, I'm going to use alpha particle. Alpha particle is the nucleus of helium, which consists of 2 protons and 2 neutrons, which is mean it's 4 times this value. So it's a massive particle compared with the electron. So he saw that if the Thomson model is correct, so I'm going to shoot the atom with alpha particles, and as a result, I'm going to collect these particles in a straight line either side of the sheet or the matter which I'm going to test or check. So guys, here's the plumb model of Thomson. Here is the sheet, gold sheet, a part of the gold sheet, and I'm going to shoot, or not me, Rutherford, shoot the sheet with alpha particle. In his hypothesis, if the model is correct, that's mean the alpha particle going to pass through the sheet in a straight line without any reflection, diffraction, anything. It's going to just move in a straight line. By this way, alpha particles, which consist of 2 protons and 2 neutrons, moved through the sheet without any change in its direction. But it didn't happen. He found that the particles are diffract and change its direction. Some of them return it back, some of them change its direction, and most of them pass in a certain direction or can move through the solid sheet without diffraction. Few are reflected back. Some change its direction, diffract from the direction, as you can notice, and the most passed without any change in its direction. So guys, as a conclusion of Rutherford, he said that inside the atom there is a massive particle in the center, at the center. This particle is greater than the alpha particle, is denser than alpha particle. So when some of alpha particles collide with this massive particle, it reflected back. And it has a positive charge because the alpha particle, which is positive, when it passes beside this particle, it repelled with this particle and changed its direction. And The rest of the atom represent empty space or a space which is contained the electrons, and he called it energy level or even the area of electrons. At this area, the alpha particles were able to move directly without change in its direction. So, Rutherford experiment used alpha particles, which are massive positively charged particles that move at high speed. Alpha particles are represented by a symbol alpha. The tiny massive positively charged central core of atom is called nucleus. He, by the end, discovered the nucleus and put a new imagination for the atom after the Thomson model. As we said, guys, we have two types of spectrum. One of them is called absorption spectrum and the other one is called emission spectrum. What is the difference between them? Let's say that we have an electron which exists in the ground state, rests at the ground state, and a white light is falling on this atom. This electron going to absorb amount of energy. This amount of energy is equal to the difference in energy between the ground state energy level and the excited state. To jump from the ground state to the excited state. The passing light will lose the frequency of the light absorbed by this electron. And in a film sheet, we'll notice all of the spectrum of all lights that exist in the white light except the absorbed one. It will be dark because this frequency, this energy of this light is absorbed and this light no longer exists in the white light. After that, this electron is going to emit the energy again, back again, and on the sheet you will find the absorbed one and released back in the form of a black sheet and only bright signals, as this one, guys. Here, the absorption. We can notice all of the light from the white light except the absorbed one. It appears as black light, black signals. While here in the emission spectrum, the light will appear as a bright signals and dark film. So, to make a comparison between absorption spectrum and emission spectrum, absorption spectrum appears dark lines on a bright background. Emission spectrums appear like a bright lines on a dark background. Process absorbing light energy gain for emission emitting light energy lost by the electron. Cause the light absorbed by atoms or molecules. Here light emitted by atoms and or molecules. Absorption spectrum. Example, a sunlight passes through a gas cloud. Light from excited hydrogen gas. When the electrons are returning back to the ground state. Scan the QR code and watch the video, guys. So what is the ground state? An atom with the smallest allowable amount of energy. What is the excited state? An energy level above the ground state when the atom gain amount of energy equal to the difference between the ground state and the excited state. Atoms in excited states have electrons in larger orbit, because energy is quantized and energy is released to the size of the orbit. The size of the orbit also quantized. Energy of the photon is equal to HF is equal to negative delta E of atom. Delta E of atom is the energy of an atom absorbed or released by the atom. So guys, if you are going to talk about the energy levels surrounding any nucleus, we are going to say that the closest energy level from the nucleus is the one with the lowest energy level. As we move away from the nucleus, the energy of each energy level increases. So, for that, as we said, any electron going to move from the lower state, from the lower energy level, the ground state, to the excited state, it needs to gain energy, and when the electron moves from the excited state to the ground state, it loses electrons. For example, if we are going to talk about hydrogen atom. For hydrogen atom, we know that hydrogen has only one electron. So, this electron exists in the first energy level, which n is equal to 1. Moving from the first energy level to the second, to the third, to the fourth, by gaining amount of energy equal to the difference between the ground state and the excited state, this energy is equal to the difference between the two energy levels. To find and measure the value of energy of each energy level, we use this rule, negative 13.6 electron volt multiplied by 1 over n squared. So En, which is the energy of such an energy level n, is equal to negative 13.6 electron volt multiplied by 1 over n squared, where n is the order of the energy level. By the way, to convert from electron volt to coulomb, we multiply by the charge of the electron 1.6 times 10 power negative 19. Here is the transition, guys, from any excited state to the ground state, which is equal to 1 to whatever. If you are talking about the ground state is n equal to 1. So we have different transition from the 7th energy level to the 1st, from the 6th to the 1st, from the 5th to the 1st, from the 4th to the 1st, and so on to reach the 2nd level to the 1st. This group of transition called lemon series, as the ground state is the first one, equal 1, and the transition from any higher energy level to the ground state. Balmer is the transition from higher energy level to N2. Bation is from the any one of higher transition to n equals 3. Bracket from any higher transition above 4 to 4. Notice that in lemon series we have 1, 2, 3, 4, 5, 6 transitions, which is mean from 7 to 2nd, from the 7th to the 2nd group of transition. All of them, the electron move to the first energy level. While here, the transition of any energy level from above the 2nd to the 2nd. So we have only 5 transitions. We have here for patient 4 transitions and bracket only 3 transitions. Each transition of this transition describe a different type of light emitted. As in Lyman series, all of the transition provides in the range of ultraviolet light, has a wavelength from 10 to 400 nanometers. Balmer, visible light. Bayesian, infrared. Bracket, also infrared. So know that the first one is lemon, has a transition in the region of ultraviolet light, and the wavelength is the range of 10 nanometer to 400 nanometer. The next one is Balmer. It's the visible light which we can see from 400 nanometer to 700 nanometer. After that, the infrared, even to be patient or bracket. Patient from 700 nanometer to 1 millimeter, and bracket from 1 millimeter to 1.8 millimeter. These numbers must be memorized, guys. Which of the following best describes the electron cloud model of atom? Electrons exist in a region of probability around the nucleus. Which is the primary role of stimulated emission in a laser? Amplifying the light through photon emission. In Rutherford experiment, what caused the deflection of alpha particle? A dense, positively charged nucleus. Which process occurs when an atom absorbs a photon of light? The electron transition to a higher energy state. The equation of E photon equal EHF minus delta E of atom explains the relationship between photon energy and the atomic transition energy. Well done, guys. What happens when an electron in a hydrogen atom transition from n equals C to the n equal 2, which is going to lose energy. The third energy level has a higher energy than the second. And this energy produced in the shape of, in the form of light, and the light is photon. Photon is emitted. So guys, we're done with this lesson. Study well and prepare yourself for the live session. And good luck, inshallah.